This is 4.2, increasing and decreasing functions. And yeah, so this is about basically the first derivative and what first derivative can tell us. And well, yeah, it can tell us whether the function is increasing or decreasing. And yeah, let's write it down. So first derivative will tell us whether the function is increasing or decreasing. Or decreasing. Right, so in other words, whether the function goes up or down. Right, so increasing would be something like this, decreasing something like that. Okay, and let's look at the first simple example. So example 1. And it goes like this. So we'll take a look at just f of x equals x squared. So consider f of x. And, with this function, I'm just going to give you some intuition of what's going on. Okay, so, right, keep in mind that if you take a first derivative, right, I always repeat it, gives you either slope, right, or it gives you formula for a slope. So in our case, in this case, it's just a formula for a slope, right? So f prime of x equals 2x. And if we want to find slope, we just take some x, right, and plug it in, and we get the slope. So, and when the function is increasing, right, so the function, the slope would be positive. Function is decreasing, the slope would be negative. Right? I hope you understand that. So here's just a sketch of that x squared, right? Just a simple parabola. And now you can see that here, right, on the left, if I pick a point here, right, so some negative numbers, the slope or the tangent line will look like this, right? So the tangent lines to all the points to the left of 0. So for all the negative x's, right, the slope will be negative. And you can see that the function is decreasing. Okay, so let me maybe draw one of the, right, some tangent line. That's not. Let me try again. Let me pick a certain point, like let's say here, so -2, right? So for -2, maybe the tangent line, and you see that the function is decreasing. And we always think about it when we go, just like, right, we do in Western culture. We look at things from left to right, right? So if I look at this graph from left to right, you see that the function is decreasing. Okay, and here on the right, we can pick another point. Right, again, we're looking at the function from left to right, and yeah, the function is increasing. And also, if you pick a couple numbers, right? So for x equals -2, right? So f prime of x, right? So slope at x equals -2 would be 2 times -2. So that slope will be -4, right? So you see that the function is decreasing, the slope is negative, and then for let's put that -2 here. Okay, and then for positive 2, so we're here, so x equals positive 2. F prime, I should have put that, let me change that. Let's put that negative 2 here. Okay, so f of f prime of negative 2 is negative 4. F prime of 2, right? So we'll have 2 times 2, so that's 4. Right? So the function is increasing, so decreasing. Okay, let me try again. I touched the screen. So where are we here? So decreasing and increasing. All right, so our task in this particular section will be determining whether in certain interval the function or the first derivative is negative or positive. All right, so let's do another example. So example 2. Okay, so again, right, we consider f of x equals x cubed. And let me write that the whole kind of example, the whole thing that what we have to do. So consider that function, determine, or find maybe. Find is a better word in this case. So find where the function is positive or is increasing. Increasing and decreasing. Okay, so we have a function. Let's take a derivative of it. So f of x equals x cubed. So f prime of x equals 3x squared. Okay, and let's do it the same way as we did the previous example. Meaning, let's just look at the graph. And this is a pretty simple function. We don't have to do any calculations here. So let's just look at the graph. And here's the graph of a cubic function. And I'm just sketching it. And you can see that wherever you, and if you draw the tangent line to the graph here, and the slope will be positive. And so the function is increasing. Same thing here. So we will say that the function is increasing from negative infinity to positive infinity. So slope is positive. Even if you look at this point right here, right? So if you calculate slope right there, let me get the, okay. If you calculate the slope right there, then you get the slope equals 0, right? But even though the slope is 0, the function is also increasing in this particular point at the origin, right? Because when you look at the definition, right, the definition basically tell us that. Well, I'll give you a definition in a moment. The idea is that if you take, right, if you look at that origin and then you move to the right, just a little bit, then you see that the slope will be positive. If you move between those 2 points, and then if you move to the left, so it's going to be something like this. Again, the slope will be positive. Okay, so that's why even though the slope is equal to 0 at the origin, the function is increasing everywhere. Okay, so let's write it down. So increasing on an interval from negative infinity to positive infinity. And yeah, let's write the definition. Okay, so definition goes like this. Function f is increasing on an interval it's actually a closed interval, so we need a bracket here from a to b. If a is less than b, then f of a is less than f of b. Okay, so yeah, let me draw the situation. Okay, we can use that cubic function. Okay, so let's say, right, so we can, this example. Right, so when we talk about increasing decreasing function, right, we always talk about the interval. So let's say I have my a, or this could be b. Right, so b would be here, a would be here. So now, right, you can see that f of b okay, so f of b would be, let me pick a different color. Right, so f of b would also be at the origin, right? So f of b would be at the origin, and f of a would be here. Okay, so the definition went something like this. So if a is less than b, right, f of a is less than f of b. And so this was increasing function. And so that's why right, that at the origin, even though the slope is 0, the function is still increasing. And because we always think about some interval. Okay, so in general, so let me write it down in general. So let the function be continuous on that interval. On AB and yeah, differentiable. Right, so everywhere in that interval except the endpoints, then 1. If f prime of x is greater than 0 for for all x's in that interval. Then f increases on that interval. Increases okay, then similarly, right, when problem 2 then if f prime of x is less than 0, then the function decreases. On that interval. Okay, and then point 3. So if f prime is if f prime of 0, f prime of x is equal to 0 for all x's in that open interval, so in AB, then f is constant. On AB. Okay. Yeah, so yeah, keep in mind we're talking about an interval, right? Not just one point. All right, so let's look at another example, example 3. Let's look at something slightly more involved. Okay, so here's the function given f of x equal to x cubed, and then we have 3 minus 3 over 2 x squared. Right, so that's the function, and we need to find intervals on which f is increasing and decreasing. And decreasing. Okay, so the first thing, let's take a derivative. So f prime of x. So derivative of x cubed is 3x squared. And now derivative of negative 3 over 2x squared is just 3x. Right? I'm moving that 2. Right? 2 goes to the front, subtracting 1. So 2's cancel out, and we get just 3x. Okay, so let me factor the 3x out. So we have 3x, and then we have x minus 1 in parentheses. Okay, so what we need to do right now is to figure out when this function, right, first derivative, is positive and negative. And I hope you remember from the previous lecture that right, right? When we find those critical numbers give us maxima or minima, right? So the function will change direction, right, at that minimum or maximum, right? So we could have something like this, right? Or we could have something like that, right? So that once we have those points, right? Okay, so the way we'll go about it, we'll find this point, okay, and then we'll figure out what's happening to the left of that point, right? So over here and to the right. Okay, so that's how we're going to go about it. Let me erase that. So to find the critical numbers or critical points, we make the first derivative equal to 0, and then we solve it. Okay, so we have 3x, and then we have x minus 1 equals to 0. Okay, so x is equal to 0, now our x is equal to 1. Okay, so at this point, so maybe let me just write it right, that these are critical numbers. So critical numbers. Okay, so what we'll do, we'll take those critical numbers and put them on number line. Okay, so we have 0 and 1. So 0 and 1. And let me make those numbers blue. Okay, so we have 0. And I'll try to keep the same colors, right, for this entire lecture and the next one as well. Okay, blue, critical numbers are blue. So now, right, so we created 3 intervals, right? So we have this one, and this one. And the only thing we have to do is figure out what the sign of that first derivative is in this interval, and this interval. Okay, so what we'll do, we'll pick, I'll call them testing points. Okay, so testing points, so this could be -1. This could be any number as long as it's left is to the left of 0, right? And then maybe this one, half, and then this one, 2, right? So these are testing numbers. And what I'll do, I'll take those 3 testing numbers, right? 1, 2, 3, and I'll plug them into the first derivative. Okay, to figure out whether that function is positive in that particular interval or negative. Okay, so let's start with -1. Okay, maybe I'll actually do the arithmetic, right? So we're doing f prime of -1, right? So that -1, this is, that came from that, right? I picked that testing number from that first interval, from this interval. Okay, so f prime of -1, and we're just plugging in that -1. So we get 3 times -1, and then -1 minus 1. And we're not really interested what that result is, right? So we kind of have to do arithmetic, but we don't really. So I kind of think about it like this, right? So this will give me negative, and this part will give me negative, this part will give me negative. So negative times negative is positive, right? So I'm just going to write positive, right? I don't really care what the number is. I guess it's +6. I'm not sure. And then when the function is positive, let's make it red also, right? So I would put like plus here, and then that will tell me that the function is increasing, right? So I'm going to make an arrow that goes up. Okay, and then yeah, we'll do the next one, right? We'll do the next point, next testing number. So we plug in that number into the function, and we get 3 times, right? So I'm here 3 times positive number, and here I get positive 1, positive half minus 1, so that's going to be negative. So that second interval, right, will be negative. So this will be negative. Okay, so here the function will go down. Right, and you can also kind of see that the 0 will be maximum. Right, so that 0 will give us a maximum, right, because the function goes up here. Right, you see that function goes down. So there'll be something like this, right? The function goes up and then goes down. So maximum. Okay, so let's check our last testing point, which is 2. Testing number point. Okay, so I'm plugging in that 2 into the first derivative. So I'm going to get 3 times 2, so that will be positive, and here positive, so the whole thing will be positive. I should have used more different colors. Okay, and the function will be increasing. Okay, so let me, what should I do? Let me change those colors actually. Right, so let's make the positive maybe green. Right, so plus, bunch of pluses, so that's increasing. And negative or decreasing, let's make it yellow. Okay, so minus, 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 and it's decreasing. And again here we'll have green, right? Okay, so here again I have plus, right? Plus function is, first derivative is positive, and the function is increasing. Okay, so yeah, we found the intervals. Let's write them down quickly. So increasing. All right, so we have those 2 intervals from okay, so increasing, let's take green. And we have 2 intervals. So the first one is from negative infinity to 0. And then the second one, let's put that connector here, from, right, and don't get confused by that, right? So we were using those testing points, testing numbers, right, those red numbers, just to test, right? So now when you're writing the answer, right, we're looking at the blue numbers, at the critical numbers. Okay, so increasing there in those 2 intervals, and decreasing. So it was decreasing from 0 to 1. Okay, so we have that, and yeah, I have a graph here. Let me show you the graph of that function. Okay, so I have, it goes through the origin, and then has, let's mark that as 1. Right, so this was the origin, 0, 0. We decided that was maximum, right? And that kind of, let me erase that one. Alright, so we have a point here. That's 1. And then 0, 0. And the graph looks something like this. Okay, maximum there, then minimum here, and it goes off to infinity. Okay, so that's the graph of the original function. And now, so you see decreasing, right? So we have the decreasing from 0 to 1, right? So we have it here. So that part is the decreasing. That's our minimum. And yeah, maybe pause the video and figure out what is the, right? So I have that 1 here. I wish I knew how to undo this, but I'm sure it's not difficult. Anyway, so let me redo that function. Okay, so decreasing on that interval, and try to figure out what are the coordinates of this, right? So it's 1 and then what? And how can we figure out what that y value is? Anyway, so that was decreasing, and I believe increasing where the color was green. Okay, so that's where the function is increasing, right? Those two intervals. Okay, so I hope you figured out what that number here is, right? And we can figure it out simply by plugging in 1 into the original function, right? So I have, what do I have? I think I have -1/2. Okay, so 1, -1/2, right? So that's the minimum, 0, 0 is the maximum. This is 2. Okay, so let me just write this, right? So f prime of x was greater than 0 here. F prime of x on this side was also greater than 0. This is not supposed to be 2. It's supposed to be greater. And then here, right, that interval was the derivative was less than 0, right? F of x is less than 0. Okay. Yeah, so let me maybe summarize this whole process, so guidelines. And so the first step was to take a derivative, right? So take a derivative. Second step was to find those critical numbers. So find critical numbers. And by solving. Right, so we take that first derivative that we obtained from that first step, and we make it equal to 0, and we solve it by solving this equation. Right, so we find those critical numbers, and then number 3, step number 3, use the numbers, or use the critical numbers. To locate the increasing, decreasing intervals. And then the last point, that was 4, use the testing numbers. To determine if f of x is less than 0 or f of x is greater than 0. Okay. Yeah, so that's the process, and that process will get even more complicated. But for now, I kind of mentioned that the idea of those maxima and minima, right? So we had this maximum here. Obviously, it's not an absolute maximum, right? Because there are points on the graph over here that are higher than this. Right? So this is just a relative or local maximum, local minimum. Okay, so next comment will be about those local extrema, and it's called first derivative test. First derivative test. And basically it tells us, right, which point is a relative maximum and which one is relative minimum. And it goes like this. So let's see, be a critical number of f. Critical number, like somehow my writing is not as good as it used to be. Critical number of f. And now, right, if f prime changes from positive to negative, at C, then that point is, well, what is it, right? Think about it. Maybe pause the video. Is that going to be positive? Is that going to be relative maximum or minimum? Okay, so let's think about it. Maybe let's draw a little sketch here. So if f prime changes from positive, right? So we have positive, right? So it's going to be increasing to negative. Right, so the function will look something like this. Right, so I'll have relative maximum. Okay, and then you can write the same part of the definition for the relative minimum. Right, so the function will be changing from from negative positive, then I'll have the minimum. Okay, let's do more examples. So example f4. Okay, and I'm just going to write the function. So f of x. So this time it's one of the terms is a sine function. So minus sine of x, and yeah, so we're just going to do it from 0 to 2 pi. So on this interval from 0 to 2 pi. Okay, so let's start with the first derivative. So f prime of x will be, right, so derivative of, we have two terms. Derivative of that first term is just going to be half. So 1 over 2 minus derivative of sine is cosine. So cosine x. Okay, right, so now following our guidelines, right, we take that, we took the first derivative. Now the second step was make the derivative equal to 0, so f prime of x is equal to 0, right? We need to locate those critical points, critical numbers. So what do we have? So we have half. And let me redo this half. Okay, so I have, so we have half minus cosine, so 1 over 2 minus cosine x equals 0. Okay, so I subtract half from both sides and I get cosine x equals half. Okay, so we need to figure out, basically we need to solve this equation, figure out when cosine is equal, for what angle cosine is equal to half. And there's many ways to do it. My favorite way is just kind of to think about it. Right, I don't recommend memorizing anything. Anyway, so cosine is adjacent over hypotenuse, right? So we can draw that special triangle here. That special triangle, this would be 1, this is 2, and this is square root of 3. And this is the case when that angle is 60 degrees, or pi over 3. So that's going to be one of our solutions. The second solution will be, right, because will be here, right? Because cosine is positive also in that fourth quadrant. And similarly, right, this is radical 3 or negative radical 3 if you want. This is 2. Okay, and then when you look at it, cosine is adjacent, right? So 1 over hypotenuse over 2, so that works for 60. And then since we're doing our interval was from 0 to 2 pi, right? So we're looking at angles from 0 to 2 pi. So that second angle will be like this, right? It will be from here to there. Okay, so that angle is, actually it ends, right? It ends at that hypotenuse, like somehow that arrow went a little bit too far. So it should be like this. Okay. All right, so this angle, so it's basically, right, we're thinking this angle here is pi over 3 or 60. And here we'll have 6 pi over 3 will be all the way around, but one of those pi's over 3 away, so that's going to be 5 pi over 3. All right, so we solve this. So x equals pi over 3 or 60 degrees, pi over 3. And then the other x was 5 pi over 3. Okay, so that was the second step, I believe, or the third step, right? The first step was finding the derivative. Second thing was solving the equation to find critical numbers. Next step was to, right, we locate those intervals. Okay, so we have, let's put 0 here. Now this is pi over 3. And here we have 5 pi over 3. Okay, so critical numbers were blue. Right, so let's make it blue. Let's just make it like blue. Okay, so this was pi over 3. This is 5 pi over 3. And yeah, remember that the 0 is not, I just put that 0 there. I'm talking about this. Just kind of, it's good to have 0 in the number line, right, to see where we are. So we're to the right of that 0, and we have 3 intervals, right? So we have this interval, and then this, and then this. And we'll pick couple numbers to test our first derivative. Okay, so 0 is a good number, and then something between pi over 3 and 5 pi over 3. Right, so I'm thinking it would be easy to, right, evaluate our cosine 4. I guess, so I'm looking at this. So I'm picking some kind of angle between pi over 3, right, between this and that, and I think the simplest would be pi, right? So pi, and then the last part, maybe I'll pick 2 pi. Okay. Yeah, I guess problem with 2 pi is that it's not in our interval, right? But I don't think the value of the derivative will change much, right? If we move just a little bit. We could pick I don't know, 11 pi over 6 or something like this. Anyway, right, so what we're doing next, we're evaluating our first derivative for those three testing numbers. Right, so let's write down that derivative. It went f of x half minus cosine x. Okay, so we're doing f prime of 0, f prime of pi, and f prime of 2 pi. Okay, so f prime of 0. Right, what I'm doing, I just kind of remind you, plugging those those testing numbers, the red ones, right? Plugging them in here. If I take the blue ones, right, if I take these numbers, critical numbers, and plug them here, I would get 0, right? Anyway, yeah, so that 0 goes in here, right? 0, and we're trying to figure out what the value is. The value is positive or negative. Okay, so 1 over 2 half minus cosine of 0. I'm going to do just the first one for you. You can do the rest if you want. Okay, so cosine of 0 is 1, so half minus 1 is going to be negative. Okay, and then f prime of pi okay, so f prime of pi, what is f prime? Actually, let me do it, why not? Good exercise for everybody, including me. Okay, so minus, now I'm doing cosine of pi. Okay, so we have half minus cosine of pi. Cosine of pi is negative 1, so we have half plus 1, so positive. And then, yeah, maybe, because technically that 2 pi is not part of our interval, right? I'm talking about this interval. So let's actually pick a different angle. Let's pick 11 pi over 6. Okay, just maybe slightly better exercise for you. All right, so the last one, and we're doing f prime of, and let's make it red. So 11 pi over 6. Right, I just picked that 11 pi over 6 arbitrarily, right? So I could pick any angle as long as it's between 0. Well, it needs to be right to the. I'm talking about this, right? It needs to be in this interval, right? It needs to be between pi or between pi over. Well, no, between 5 pi over 3 and 2 pi, right? So it needs to be here. Right, some angle, and cannot be technically it cannot be 2 pi, right? Because 2 pi is not in our interval. Anyway, so we picked that 11 pi over 6, right? So that 11 pi over 6 will be somewhere here, right? So this would be the angle, 11 pi over 6. I hope you remember something from trigonometry. Okay, so let's finish it. So I'm doing half minus cosine of 11 pi over 6. So I have 11 pi over 6. Okay, so that is still half. 11 pi over 6 is positive, so I'm going to get minus, and 11 pi over 6, let me do it again. Okay, so 11 pi over 6 is here, right? Then if I draw that special triangle, that would be 1 or negative 1, that would be 2. and that would be radical 3. Okay, so cosine was adjacent over hypotenuse, so that's positive radical 3 over 2. Okay, so radical 3 over 2 is bigger than half, so that's going to be negative. Okay, so negative. I forgot that, I forgot about that number line. Anyway, and of course I forgot the colors. So let me look at the colors. Okay, positive was green, negative was yellow. Okay, so the first interval was negative. Alright, so I'm just putting a bunch of negative signs here, and the function is space here. Function is decreasing. Okay, then for that second interval I have positive signs, so plus 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 plus, and the function is increasing. Okay, and then for that for the last interval it was also negative, if I remember right. Yeah, negative. The last interval is here, and the function is also decreasing. Okay, so now, right, we can see where I have those local maxima and minima. Okay, so function is going down here and right here, so this will be minimum and this will be maximum. And you see how, right, kind of it's good to draw those arrows. Maybe that arrow could be a little bit closer and you can see it better. Okay, all right, so you see, you see how that the shape of the function is like this, right? So this point will be the minimum, and now over here the shape of the function is like this, so this point will be maximum, right? And that's what the first derivative tells us. And let's finish that problem with the graph. Okay, so we have, this is pi over 3, so that's gonna be one of the, maybe I'll put that up here. So pi over 3 was the minimum, I believe. Then we'll have pi here, and we'll have 5 pi over 3. Okay, and then we'll finish with 2 pi. Okay, and the graph looks like this. So that point doesn't belong to the graph. And we have minimum here, and then we have maximum at 5 pi over 3. Okay, so the graph looks like this, and then crosses, and then this is gonna work out. I don't know. Let me try again. Okay, so we go down here, then we cross, we make that maximum here, and then after that function goes down, and here that for the 2 pi we have open circle again, right? Because 2 pi doesn't belong to that interval we're interested in. Okay, so we found those minima and maxima. So let's write it down. So increasing or decreasing, function is decreasing. Yeah, I didn't really specify what our task was in this problem, right? But that was right. We were supposed to find the maxima, local maxima and minima, and intervals where function is decreasing and increasing. Okay, so decreasing, if I remember right, was color was yellow, and it was from negative infinity to pi over 3. Oh no, it's not. It's from 0 to pi over 3, 0 to pi over 3, right? And then also from 5 pi over 3 to 2 pi. right? So you see those two intervals, right, over here and over here, and then increasing. All right, so that was green. Increasing was from pi over 3 to 5 pi over 3. Okay, so we have that, and then we have maximum and minimum. So minimum at x equals pi over 3, and then maximum at x equals 5 pi over 3.